Alright, so here are all the images that we either took photos or downloaded some off Google, probably half and half about. We have a total of 278 images, all these different labels here dealing with signs and lights that a car would have to deal with on the road, mostly things that would dictate a autonomous vehicle's speed. So we'll go through and just give some examples. Chevrons, so obviously the car would want to slow down and also know that it has to navigate a turn coming up, so it wants to be able to see those. We have crossing signs, so this can be people crossing signs or also like deer crossing signs, stuff like that. They're all shaped, in this yellow diagonal look. So we group all those together. Just that would ideally tell the car to slow down a little bit if you see a sign like that. Do not enter signs, which is pretty obvious, would tell the car not to go that direction. Green lights, obviously you got to be able to see a green light to know that it's safe to proceed through an intersection. No passing signs to know that, even if you're following a slower vehicle, the autonomous vehicle will not try to pass. One-way signs, so you know which way to safely travel a road. Red lights, so you know when to stop in an intersection. Speed limits, so you can look at a speed limit sign and know how fast to go. We did not separate the different speed limit signs, so that would be another layer of software or something. If it sees a speed limit sign, then go into this program and say, oh, is this a 45 mile an hour, 35 mile an hour, or whatever. Stop signs, obviously pretty simple. They're going to be a lot of those out in the wild for autonomous vehicles to see. Then we also did yellow lights too. All right, here's just a look at the evaluate tab of some of our stats, I guess, for our model. This is one of the earlier iterations. You can see precision at 83%, recall at 89%, the trade-off curve there, and the intersection points. And then as we worked up, got a little better. The area under this trade-off curve got a little bigger, and these numbers are getting a little bigger, all the way up to our newest model here, which has a 97% or a 0.97 under the precision recall curve, and 90% precision and 94% recall. All right, so now we can go ahead and train our model, or test our model, I should say, using the upload images way to do it. And you can do 10 images at a time, so we'll just go ahead and take all 10 of these in this test set. These, of course, are not used to train the model at all. These are new pictures. All right, so we'll see what signs it recognized from at least the signs that we trained it to look for. Looks like right here it got both these speed limit signs, so that's good. It said 100%, that's a speed limit. This one was only 56%, probably because there's only one line of text. Usually I think most of the training images, they have 2 lines of text, but it still got it, so it's, you're all good. Right here it sees the stop sign and the yield sign really clearly. We did not train it to look for railroad crossing signs. That, if you were to expand this, obviously you'd want that, but we didn't do that. Down here, it got all 3 of these do not enter signs, which is good. I got one of the 2 red lights. It didn't see this one in the corner here for some reason. At least it got one, so it's going to stop. The good thing about, I guess, intersections, traffic lights, there's usually at least 2 traffic lights in an intersection, so it's kind of a built-in redundant feature as far as autonomous cars with cameras, because as long as it sees one red light, it'll stop. It doesn't have to necessarily see them both. It's for the multiple lanes. So it looks like this one here, in the lane that the car was in, it saw that red light. Down here there's 2 green lights and 2 red lights. It saw all of them. Obviously, depending on what lane this car was in, it would have to be optimized to look at the right traffic light, but it did see all of them. Down here it sees this no passing sign as well as the speed limit sign, which is good. We didn't obviously have it read the numbers on the speed limit sign. That'd be the next step. Down here it sees all of these chevrons coming up, so it can alert the control that there's going to be a curve coming up, how to navigate that. A lot of signs going on in this picture. Again, we didn't train it to look for everything, but it did get the things that we trained it to look for. It got all these green lights up here. It sees this do not enter sign, knows not to go through the intersection into that lane, and it sees this crossing sign here, so it knows, probably want to slow down a little bit and be on the lookout for pedestrians right there at the intersection. Down here, it sees the stop sign and the chevrons again, so get ready to navigate a turn. This picture is really blurry. I think any modern autonomous car would probably have a better resolution camera than this, but it did still see all these red lights, so it would stop. There's a speed limit sign, it looks like, through the intersection that it didn't see. Hopefully, as it gets closer, when it needs to actually see that speed limit sign, it would pick it up. This image here, it sees both of these green lights, so it knows it can go, but there is this crossing sign, so ideally it would kind of proceed cautiously and look for pedestrians. Alright, so that's all 10 of the pictures that we used in our test set. Alright, here's just a quick look at the Python code that we use to analyze some of the images. Most of this code is provided by Google Cloud, so we just copied and pasted it. Just had to add a few lines up here because we had some problems with credentials, so pretty much just made a JSON file and stored that locally on my computer, so that this code looked that up and made sure that we had the credential key to use our project, I guess. But yeah, so there's a look at the little bit of Python code that went into it. Alright, so now let's go ahead and test our model using Python code. So most of the code, like I said, I got from the Google AutoML. I did have to edit it a little bit to make sure everything worked, but it wasn't too bad. So we're going to call up Python predict is the file name, and then it needs 3 arguments. First of which is the file path of the picture we want to look at. Put that in. And then it also needs project information, which I think is a project ID, as well as the billing number or something it gives you. Put those in and we'll let it think. Alright, shows us all the stuff that it found. So it gives you the vertices of the bounding boxes, so it gives you opposite vertices of where the boxes are, x and y coordinates, and these are normalized coordinates, so they're on a scale of 0 to 1 for x being left to right of the image. So if it's point, this says there's a stop sign that is like 87% of the way across the image going from left to right. Like that's how these box vertices work. So that means there should be a stop sign it sees, there's a red light, there's another stop sign, there's another red light, and it sees a green light in this image. And it gives you all, again, like all the coordinates for where it sees these things, and it tells you the score, how sure it is. It said it saw 2 stoplights, 2 red lights, and a green light. So here's the image that I put in. There are 2 stop signs, so that's good. I got that right. There are 2 red lights, so it got that right. And there actually looks like there's 2 green lights, but they're pretty far in the distance. It saw one of them, but ideally it's able to discern, the red lights that it saw. It was 76% sure of that one and 95% sure that it saw another red light, and it was only 69.5% sure that it saw a green light. So this car would stop. Obviously it sees all these red lights and stop signs. So let's look at how you can also test these models using Python code. And obviously this is it's given us a whole bunch of lines of data and everything, but you could pretty easily put all that data into vectors or something and have it output into a CSV file or something like that with a little bit easier to read and things, but we didn't look too far into it. That's just a little bit of how you can use